Developing a study to test a new teaching protocol can be a really exciting time for educators. This is a time to develop a new and innovative teaching tool, to try it out on a set of sample participants, and then prove to everyone the effectiveness of your treatment. However, I've seen many teams struggle for hours and hours to get down the right study protocol. But it doesn't have to be that hard. My name is Jeffrey Franck. I'm a statistician and the CEO of Stat59. In this video, we're going to look at a three-step process that can help you very easily design and implement your own quasi-experimental study. We're going to look at three aspects here. First, we're going to look at what is a quasi-experiment. Then we're going to talk about how to choose the correct design. And then we're going to give some tips for implementing your study. So first, what is a quasi-experiment? Let's go through a quick roadmap. So this is the roadmap to quasi-experimentation that we're going to use for this presentation. If you don't have this in your hand, I urge you to pause the video now and download the infographic using the link in the description above. That'll help you to follow along. When should we use a quasi-experiment? Well, there are a number of instances when we should use quasi-experimentation. Usually this is some type of intervention where randomization is simply not possible. Sometimes we're studying a natural phenomenon. Maybe we're doing a screening study. In educational studies, it can be sometimes considered either ethically inappropriate or logistically difficult to randomize students to one of two different interventions. But the advantage of quasi-experimentation is that in the end, we can analyze this very similar to a randomized study, and it does provide pretty good evidence of the effectiveness of our teaching intervention. To further understand this in this presentation, we're going to use a small case study. So here's our case study. Our case study is a small startup who has invented a new teaching program. And this is a teaching program designed for workers in the oil and gas industry to quickly learn about hazardous materials management. And their new innovative program contains an online teaching module and then a downloadable app. Participants download the app, and then the app sends them a daily reminder with a sort of tip of the day for hazardous materials management. Now, the value proposition for this startup is they feel that they can deliver very effective training, and this costs much less than holding on usual traditional in-class presentations. So what they're going to do here is they're going to need to try to prove to their customers that this indeed does work. So let's move on from what is a quasi-experiment to how to choose a design. And this is where a lot of people get mixed up. Again, we're going to talk about this three-step infographic. And the infographic basically shows how to do the design of a quasi-experiment in three easy steps. And we're going to ask ourselves three simple questions. Can you randomize? Is it possible to randomize the participants to either receive the intervention or not receive the intervention? Can we have a control group? And can we have a pretest? So let's start with the first question. Can you randomize? And let's assume yes, in this case we can. If we can, then these are randomized designs. And if there is any possible way that you can randomize your participants, then you should do it, because this makes much, much stronger evidence of the efficacy of your intervention. By randomize, I mean that each individual participant has a chance of being assigned to either getting the educational intervention or not getting the educational intervention. And this could be such designs as parallel groups design, multi-arm parallel groups, crossover designs, cluster designs, or factorial designs. We're not going to cover much about randomized designs in this presentation. If, however, you think you can do a randomized design, I encourage you to take a look at our recent blog post that shows 5 easy ways to develop a randomized study. The other type of study design that's very common in education is a very effective and slick educational design called the randomized Solomon 4-group design. And again, if you can randomize your participants, then I encourage you to take this path. Check out our YouTube video on the Solomon 4 group if you want to know how that works. So the answer to that first question, can you randomize? If you can, then you should choose a randomized design. If you can't, then we're going to choose a quasi-experimental design, and then this video is for you. So moving down the flowchart, we've gone through, we said, can we randomize? And let's assume in this case we cannot. The next question that comes down is, can we have a control group? And a control group is a group that does not receive the educational intervention. So here we see that if we say yes, we can take designs with a control group, then we get to ask the next question. And the next question is, can you have a pretest? If you can have a pretest or not a pretest, leads to two different paths. So let's assume that we can have a pretest. In this case, we have two options for designs, which are the untreated control group with the pretest and posttest, and the matching with cohort control. Now, the untreated control group with pretest and posttest, this is sort of the quintessential quasi-experimental design, and this is the one we all like to have and the one we should aim for. Here the participants are divided into two groups. Now we note that they are not randomly assigned to one of these groups. They are assigned to one of these groups by some other non-random process. Perhaps they volunteered, perhaps by where they lived, perhaps by different year of their educational program. There's a control group. The control group gets a pretest, and then after some time they get a posttest. Now the intervention group, on the other hand, gets the pretest, and then they get the treatment, the educational intervention, and then they get their posttest. Now ideally we like to do this at the same time, or relatively the same time, so the pretest and the posttest are relatively around the same time. So for instance, in our example for our startup, so our startup maybe can go to two separate companies. And it goes to two companies and asks them, would you like to be a part of a study where we're looking at the effectiveness of our new teaching program? Maybe we could take one company and say, yes, we're going to give you a pretest, and the other company gets a pretest at the same time. And then maybe the next day, the intervention group at one company gets their treatment, and then 6 months later, each of the groups gets their posttest. Now, the advantage of this design is that we can statistically look at the difference between the pretest and post-test scores for each individual person, and then we can compare that. Ideally, what we would like to see is that there's a big increase on the post-test scores compared to the pretest scores in the treatment group, and that there's no increase or a smaller increase in the control group. And that would provide pretty strong evidence that our teaching intervention would work. Now, this design is really the one that you should be aiming for in your quasi-experimental designs. So if you can have a control group and you can have a pretest and a posttest, then this is the design to enact. Now, one of the other designs that you can use is a matching with a cohort control, another type of control group with a pretest. So here, things are separated not so much geographically, but in time. So here we have participants in the control group. So that might be, let's say, this year's training group. This year's training group simply gets a pretest. Now, if we go the next year, in the interventional group, they get the treatment and then the posttest. So we see in this case that the participants in the pretest and the posttest are not necessarily the same participants, but we do have evidence of the test scores before and after the treatment. So going back to our startup, how would you use this type of design? Well, what they might do is go to a training school. Maybe they're going to go to a school where they train pipe fitters. And they go to this training school and say, this year we would like to test all of the people graduating from your pipe fitter program to see about their knowledge on hazardous materials management. Then next year, we're going to go into that same school with a new group, the students from the next year, and we're going to give them our training intervention. They're going to get the online course and they're going to get the app with the daily tips. And then 6 months later, we're going to give their post-test. So here we still get good evidence because we have testing before and after our educational plan, but because it's a different group of people and because there is a time space between them, we have somewhat weaker evidence. So those are your two designs that have a control group with a pretest. Now, what if you cannot do a pretest? And this can be quite common. This often happens when the educational strategy has already been started and you want to study it. So there's two different ways to have groups with a control group without a pretest. So we can have a post-test only with non-equivalent groups, or we can have a case control study. Now the post-test only with non-equivalent groups is quite a simple design. Here we see participants are in two groups. One is a control group, one is an interventional group. One gets the treatment and then a post-test, where the other gets simply the post-test. And again, what we have here is some evidence of a difference between the treatment group and the non-treatment group. So what we would like to see is that the treatment group has a much higher score on their post-test than the control group. Unfortunately, with this design, we don't really know the scores. We're not comparing the scores of improvement for individual people. So if there's a type of test where there's very strong individual variation, sometimes we just can't pick it up with this design. So this design has a lot less power to pick up differences in the groups. So for our startup, how could this work? Well, perhaps the startup has already been to a company in one city and already offered them the educational program, and the people in that training program have already taken the course. Now, in order to prove it, all they need to do is do the post-test on that group and then find a similar group at another company and do the post-test on the group that has not received the intervention. So this is a very easy design, and it's very helpful if the training program has already started. Now, case control studies are kind of a different thing, and they're not as common in educational designs, but they're very common in epidemiologic studies. Here, we're looking at an intervention or a phenomena that has happened in the past. So here, what we look for is we look for people who were affected and unaffected, and then we assess for their exposure. So the classic type of design would be here, one of the classics was the proof that smoking caused lung cancer. And that was done initially by finding a group of people that had lung cancer and a group of people who were similar but without lung cancer, and looking who had been exposed to cigarette smoking. And what they found was in the lung cancer group, a much bigger percentage of them had been exposed to cigarette smoking. So how could we do this for our startup? Well, one of the ways would be to take a look. Let's say that we have already had our startup has already been out there. It's been on social media and it's already given the training course to a bunch of volunteers. So let's say 100 volunteers have already taken the course. One of the things that we could do is, let's say we get a list of all the people in the city who work as pipe fitters. And we we take 100 of them that have had an accident involving hazardous materials in the past month. And we take 100 that have not had hazardous materials. And then we take a look and see who has taken our course. What we'd like to see, or we expect to see, is that in the group of pipe fitters who had a hazardous materials accident, not many of them took our course. In the group of pipe fitters who did not have a hazardous materials accident, many of them took our course. So understanding case control study can be a little bit tricky. What it's used for here basically as a retrospective way to look at things, and it can be really, really helpful if the outcome is very rare. So that's your control group with pretests. So now moving back to our study designs, again, here we had the designs with the control group. Now, what would happen here if we went down and said no? For certain reasons, we cannot have a control group. That is, we must educate everyone in the group. Perhaps it's an ethical issue. People say, we simply cannot deny this training to some of our people. Perhaps it's a logistic issue. Perhaps there's no specific way to separate people to give some of them intervention and some of them not. So designs without a control group, now we ask the next question. Will we have a pretest or we won't have a pretest? So there are three types of designs that do not have a control group, but also do have a pretest. And those are the one group pretest post-test, the removed treatment, and the repeated treatment. Now the one group pretest post-test is a pretty simple design. We take our participants, we give them a pretest, then we give them the treatment, and then we give them the post-test. So here we are getting a comparison of the testing before and after our educational intervention. The problem is that we do not have a control group to compare it to. So one of the things that could be happening is perhaps the increase in the testing score is a natural progression. Maybe it's not actually due to our treatment. Let's take a look at an example. Imagine our startup goes to a company, a large oil and gas company, and looks at all their welders and says, okay, we're going to test all your welders on proper hazardous materials management. Then we're going to give them our training course, and then 6 months later, we're going to give them our post-test. And we see a great change in score. What we don't know, however, is what else went on. So if these are welders who are going through a training program right now, maybe they're learning their hazardous materials management on their own. Maybe it's part of another course that they're taking. Maybe they're learning it from their peers. So we don't really know. So this one group pretest post-test design gives us some evidence, but unfortunately, it allows a whole bunch of other confounders to be out there and we can't catch them. Now, the removed treatment design gives us a little bit better evidence. So here, participants run through a little bit more of a complex course. First, they have their pretest. Then after their pretest, they get a treatment. And then we do their post-test. And we hope to see that their post-test scores are better than the pretest. Then we remove the treatment. And we test again with the post-test. And we'd expect to see is that removal of the treatment means the test scores go down. So this really only works in training programs or interventions that are ongoing. So let's take a look at the example of our startup. So our startup had an educational intervention that was made of two parts. There was the online course and then there was the app. So what we could do is we could go to maybe the Union of Pipe Fitters and say we would like to offer everyone in the union a chance to do this. So we give them all a pretest, and then we give them the online course, and then we give them access to the app. And then 6 months later, we give them a post-test score. We score the post-test, and then let's say we now take away the app. Okay, they're no longer subscribed to the app. And then 6 months later, we test them again. So if the daily reminder app was effective for our design, what we would expect is very low initial pretest scores, them getting higher when they get their first post-test due to use of the app and the online course, and then gradually the post-test scores going down lower again because we've withdrawn the online treatment. Now, it's a little bit hard to know when you separate them out like that about what is normal attrition. After we give a teaching course, we expect that people usually perform better early on, and they sort of lose that knowledge over time. So this can be an effective way to look at things, but it does allow a number of confounders to creep in. Now, the repeated treatment design, which has no control group but does have a pretest, is a bit of a little buff up of the removed treatment. Here, we're going to follow a little bit more complex course. So our participants come in, they get a pretest, we give them their training intervention, then they get a post-test. Then we take away the intervention and we do the post-test. Then we put the intervention back and do a post-test. And what we expect to see, or we'd like to see, is this up and down of the test scores over time as we add and subtract the teaching intervention. So what will we expect here for our startup? Well, again, we're going to go through the same course as we did with the removed treatment. We start with the pretest, then we give the participants access to the app and the online course, and then we do our first post-test. After that post-test, we expect the scores to have come up. Then we take away the app, and we expect that the post-test scores after taking away the app go down. Then we give back the app, and we expect that the post-test scores after giving back the app go back up. So you should see this up, down in the post-test scores when you use this type of design. So this becomes a little bit stronger evidence if you can show a very good correlation that every time we add the treatment, the test scores go up, and every time we take it away, the test scores go down. That's pretty good evidence. So those are your designs without a control group, but having a pretest. So now imagine here that you have designs where you cannot have a control group and you also cannot have a pretest. This is the one group post-test only design. So here's a very simple design. We take a group of participants, we give them our educational intervention, and then we give them a post-test. And what we like to see is an excellent score on the post-test, and we can say, oh, this is fantastic. Participants have an excellent score on the post-test because we taught them. Now you can see that there's a number of big problems with this because there's no real proof that your post-test score is due to the treatment. And it's also very difficult to judge what is a high post-test score. Was the test very hard and so 25% is a really good score? Or was the test very easy, so 100% is a very good score, and anything less is considered suboptimal? These studies can work, actually. They can work under really circumstances that come from two places. One is that you have an already established, validated, standardized tests. Okay, so for instance, if you were using this to study something like CPR skills, we would use the test that we know is used by the American Heart Association. It's already standardized tests, and we know the passing grade. So it's very easy for us to say what's a good score and what isn't. And it also works best for knowledge that you would not expect people to find somewhere else. So, you know, if we take people out of the public and give them a calculus test, they're probably going to perform pretty low. And so we know that the baseline on the post-test will be low. So how would this work for our startup example? Well, perhaps what we could do is we could go to a group of people who have yet to enter into their trade. So these are maybe graduates right out of high school and they have not yet started their training. So we would expect the baseline knowledge of hazardous materials there to be low. And then maybe we could use the Department of Transportation standardized exam. And so we know that this is a valid exam. So I think if we were able to say, we took students right out of high school, we gave them our course, and they all passed the District of Transport exam, then that would be very strong evidence. So the one group post-test only exam study protocol can work, but it really has a limited set of circumstances. So again, going back here, we've reviewed all three steps here in choosing a design. Now, the thing to remember when we went through our protocol, through our infographic, is that basically you start at the top. The best design is the randomized design. Moving down, your best designs are those with control test and pretest, control group and pretest, and then moving down to the bottom, and the sort of lowest quality you're going to get is those that are non-randomized, no pretest, and no control group. So let's talk a little quickly about implementing your study. Just a quick reminder that there are other options. Okay, so if you look through a textbook, there are literally textbooks of quasi-experimental designs, and there are virtually limitless way to put these together. What I'm trying to present here is a very simple way to get a standardized experimental design that is proven and easy to implement. So we saw today that choosing a quasi-experimental design need not be difficult. Following through on the infographic with this simple three-step process, we were able to show by asking ourselves the question, can we randomize? Can we have a control group? And can we have a pretest? We were able to quickly come to an effective experimental design. My name is Jeffrey Franck. I'm a statistician and the CEO of Stat59. If you'd like to see how the Stat59 web app can help you design, implement, and report your own quasi-experimental study, please come visit us at our website at www.stat59.com.